Good day, everyone. Welcome to the third dimension. Our topic for today is 10 civil engineering short questions, which every civil engineer must know and must be familiar with. In these short questions, the concepts that we're going to learn are very important. So please stay tuned till the end of the video. Question number one: what is the least cover provided to different RCC members? Cover is the distance which separates the rebars from the exterior face of the element. As you can see in the picture, there are two different types of covers. One is clear cover and one is effective cover. In effective cover, half of the depth or the diameter of the rebars is also included. So the effective cover is, for example, if 10 mm bars are being used, then the effective cover would be the clear cover plus 5 mm. And as far as the thickness of the cover is concerned, or the cover itself is concerned, so for footings, it's 50 mm, for columns, it's 40 mm, for beams, it's 25 mm, and for slabs, it's 20 mm. You can even note the trend that we have followed here, that as we move from the bottom towards the top, the cover decreases. At the bottom of the structure, which is the footing, we have the most amount of load. So over here we have 50 mm, which means that we provide the biggest amount of cover. And in soils, we even have the different chemicals and the different, hazards, as I would like to call them, that we have for the rebars. So we have the most amount of cover is provided at the bottom in the footing, and as we move towards the upper side of the structure, at the top of the structure, so the cover decreases and the loads also decrease and the hazards also decrease. So from the bottom it's the most, towards the top is the least. So 50 mm for footings, 40 mm for columns, beams is 25 mm, and slabs is 20 mm. Question number two: what are the functions of columns in a building? Columns are vertical compressive members, and they play a vital role in the strength and stability of a structure. As you can see here, columns are vertical structural compression members which transfers the loads through different elements towards the foundation. So columns play an important role when it comes to the sustainability, stability, and strength of a structure. And they are a vital element when it comes to the load transfer within a structure. So from slabs, it's towards the beams, and then from beams, it's towards the columns. So columns transfer the loads from one floor to the other, and they provide that vertical stability and sustainability which every structure needs. Question number three: what are Siemens sand aggregate ratios for various grades of concrete? Concrete grades and the ratios. On the right side, we can see here's a small table that we have. These are the grades of concrete, and the second one is the mixed ratio, and then we have the compressive strength at 28 days, and the strength is given in MPa, or newtons per mm square, and it's also given in PSI, which is the American way of saying it, pounds per inch square. The various grades are M5, which is 1:5:10. One is for cement, 5 is for sand, which is also called as fine aggregate, and 10 is for aggregate, which is also called as coarse aggregate. So 1 cement, 5 fine aggregate, and 10 coarse aggregate. And then for M7.5 we have 148. That's also written on the left side, 148. For M10 it's 136. For M15 it's 124, which is mostly used for PCC work, plain cement concrete. And for M20, which is the most widely used grade of concrete, in fact in all RCC work, M20 is used. So it's 1, 1.5, and 3. And we have M25, which is 1, 1, and 2. And M30 is 1, 1, and 3. 1:1:3. And for example, in the table, if we talk about PSI, so 5 MPa is equal to 725 pounds per inch square. So it means that for every square inch of concrete, the cube should absorb 725 pounds of load. Question number 4. What is honeycomb in concrete? Honeycomb are air voids which are left in the concrete during casting, and their causes are mostly due to improper vibration or improper water-cement ratio, the consistency and workability, and the improper grade mix. So when the concrete is casted, during that phase, when too much water is added into it, or when it's not vibrated thoroughly, and when there's a problem with its consistency or workability, and when it's not when there's a problem with the grade mix of the batch. So, but basically, honeycombs are the left air voids, which happens during the batching or pouring or casting of concrete, and they're very common on sites. So you should make sure that the batch has enough water and it's properly mixed in the mixer and it's properly vibrated during the casting process. That's honeycombs. Question number 5. What is the initial and final setting time of a concrete mix or a concrete batch? The initial setting time of all Siemens under almost all conditions is 30 minutes, and the final setting time is 10 hours. So you have 30 minutes to 10 hours from mixing, batching, transporting, and pouring the concrete. After 10 hours, it's going to harden up. And if you want to change these properties, then you would have to add different additives and admixtures, different retarders, so that you could change the property according to what your need is. But usually 30 minutes and 10 hours. Question number 6. What do you understand by TMT bars? Well, TMT stands for thermomechanically treated bars, and TMT are stronger and have a higher resistance to corrosion as compared to other bars. Similarly, they provide an enhanced protection against earthquakes and other disasters. And an example of TMT bars is FE500, which is a TMT bar. So moving on, question number 7. What are the types of Siemens? The most common and the one which is used in almost all cases is the ordinary Portland cement, which is OPC. The second most used cement is the sulfate resistant cement, and apart from that we have the Portland pozzolana cement. Pozzolana is also volcanic ash, I believe, and the pronunciation of this may also differ, but that's how it's usually pronounced. And then we have the rapid hardening cement, in which the setting time of the mixture is decreased, so it's not 30 minutes anymore as we previously discussed. And then we have the extra rapid hardening cement. We have the low heat cement, which I believe is used for dams, in which less amount of heat is released during the hydration process. In rapid hardening cement, enormous amount of heats are released, so that's a disadvantage we have. And then we have the quick setting cement and the blast furnace slag cement, in which furnace slag is added to the mixture, about 30% of slag and 70% of cement. I believe that's what the ratio is. And these are the types of cements which we usually have in the market. And then according to the work that needs to be done, so the proper type of cement is selected. Question number 8. What do you understand by M20 concrete? M stands for mix, while 20 stands for its compressive strength, which is 20 newtons per mm square, or 20 MPa. So this is actually a way of, dividing concrete, or you could say it's a way of grading concrete. So an M20 grade concrete would have a 20 newtons per mm square strength after 28 days of its casting. So after 28 days, when the concrete is casted, its strength is going to be 20 MPa. Moving on, question number 9. What do you understand by characteristic strength of concrete. The strength of concrete is given in terms of its compressive strength of a concrete cube, which is its strength on its 28th day after it's casted. While the characteristic strength, which is the main question here, is the strength below which not more than 5% of the samples are expected to fail. So characteristic is, it's that limit, I believe, below which not 5% of the samples are going to fail. That's the main question. Let's move on. Question number 10 describe the various types of slumps. Well, slump test is the main concrete test we have on site. It is used to measure, or it's initiated to measure the consistency and workability of fresh concrete, of every concrete batch, in fact. So slump tests tells us how properly a batch of concrete is mixed. It tells us what is the amount of water added into it, and it tells us how suitable the batch of concrete is for RCC work. And in usual cases, in fact, in all cases, these are the 4 different types of slumps which we would have. The true slump, the zero slump, which tells us that very less water is added into the batch and its workability is very less, it's non-workable. The collapsed slump, this picture tells us that large amounts of water is added into the batch. In fact, this is completely, the batch prepared is not usable at all, and it shouldn't be used because the water is too much. And then we have the shear slump. The shear slump is the one which indicates a correct batch of concrete. So we should aim for the shear slump. These are the 4 different types of slumps we have. And the slump test tells us the consistency and workability of fresh concrete. So these were 10 short questions which every civil engineer must know. And thank you for watching the video. Thank you.